Hi, everybody. Good afternoon. My name is Derek Runberg. I'm going to be bumping back between my camera and my slides. If you're here, you're probably interested in how to teach the microbit, this thing, remotely with your students. And we'll go over both kind of some pedagogy stuff about teaching remotely. A lot of you have been thrown into it already. Believe me, we know. And we thank you so much for working with your students that way. But we want to see if we can make it easier and even better in a lot of ways in terms of teaching STEAM and STEM. At least in the district where I live, a lot of that has been cut from this rest of the school year down to the basics of like reading, writing, and math. And so just looking forward to next year and maybe even in your district, rest of the school year this year, how can we maybe implement some STEM and STEAM learning at home? So with that, I'm going to jump into the slides again, but I just wanted to say hi so you can see my face, and then we'll get going here. So like I said before, my name's Derek. If you want to get a hold of me, you can see my contact information down below, my email address, as well as my Twitter tag. Work for SparkFun Electronics, if you didn't know that already. I split time between corporate and strategic partnerships, working with both school districts, nonprofits, and for-profit corporations around professional development, marketing materials, as well as some product development. A little bit about me, that's me. I am one of the few remote employees for SparkFun Electronics. You can see my workspace up there on the right-hand side. I'm a previous middle school technology teacher, so I taught Arduino and processing in the classroom. And when I came on to SparkFun, I had the honor of writing 2 books that took a lot of the content that I did in the classroom and translated that for everybody else. So those 2 books, both for Arduino and processing, are some great materials for the classroom. Many of them have been translated over the past couple years to some of the projects that I've done with microbit as well. Before we jump into the goals of today, one of the things that I really wanted to do with this webinar was model some really, what I think is some good remote pedagogy. And with that is being able to interact with your learners in multiple modalities. Normally, you're able to see your student's face, you're able to walk up behind them, ask them questions, be able to see people raise their hands. One of the biggest ways or downsides of that is right now is not having that one-to-one relationship with your students. So we try our best. And one of the tools that I found, especially during video presentations like this, where I can't see any of your faces at the moment, is to use the chat box. It allows us to ask questions and answer them and kind of get things out. So the next 2 minutes, what I'd like you to do is type in what is your greatest fear around the possible implementation of microbits remotely. was about 2 minutes. Some amazing questions, and they're still coming in. And I'm hoping to answer most of them for you. A lot of the questions around cost and components and students be able to support this technology at home. How do I engage with my students? How do I troubleshoot stuff? All appropriate and amazing questions. And hopefully we'll be able to get to answering a lot of those today. So some goals for today. So introducing the idea of the 2060-60 or 2020-60 instruction. And this is an idea that really comes from agile practice in the classroom. It's an adoption of agile practice in the corporate world, but applied to the classroom. And also the idea of co-learning. So not feeling like you have all the answers. I would say a lot of good teachers do this already, but again, reinforcing this with something new where I may not know all the answers. I may barely know how to upload code to the microbit, but I'm willing to jump in and do this with my students. Introduce and share tools for teaching the microbit remotely. So we're going to look at both programming it remotely with Microsoft Make Code, and then 2 instruction platforms that all of you may or may not have used or seen before. One of them is the Microbit Classroom. Another one is a tool made by Microsoft called FlipGrid. And we'll be using both of those and demonstrating both of those. So a lot of the questions about how to connect with your students, how do I troubleshoot, both of those tools do a really good job, but in very different ways and different uses. So we'll go over the difference between those. And then how to stay in touch after this webinar. I'm a firm believer in not just presenting to the internet and saying, hey, this is a video and this is done. I want to be able to stay engaged with you as instructors and both as learners, and figure out and help troubleshoot how things are going in your classroom, your virtual classroom, the rest of the school year and into next year in terms of how you don't know where things are going to go. So I'll offer up a number of tools around that, as well as, again, model that virtual classroom as much as I can for you. So when all of this went down, one of the things for SparkFun was I instantly thought of all of these teachers who are using our hardware in the classroom, the microbit and some other things, and what does that mean for teaching things remotely? And what that means is if we can, as educators, pull this off, is that we get a choose your own adventure as a classroom. And I think of it as a positive opportunity to really change some of our pedagogical practices that have been slow to change over time. We're being forced into a new age, and this is a good opportunity to make some of those changes and play around with some different ideas as a teacher. So microbits, the Go bundle is a $16.50 kit that you could purchase from us or a number of other vendors, but we offer it as an individual kit, but also as a classroom set of 10. Using Microsoft Make Code to be able to program that works with Mac, PC, as well as, sorry, Kelly, I saw your question, $16.50 for a microbit, battery pack, batteries, and USB cable. Microsoft Make Code works on PC, Mac, as well as Chromebooks. Also, if you have an Android or Apple device at home, so an iPad or iPhone, there are apps to be able to program those remotely as well via Bluetooth. There's no sign up, no logins to use or anything like that, so it's all COPA compliant in terms of student use. And then in terms of managing your classroom and managing your students, the 2 tools I already talked about a little bit before is Microsoft Make Code in terms of their classroom, but they also have a huge body of content in terms of projects, tutorials, lessons, things like that for you to leverage with your students. Again, it's another kind of quiet typing time. I know it seems really quick since the previous one, but here we go. So I want you to respond to the next slide. do a little bit shorter time. By the way, if you see Megan in the chat, she's helping me out answer some of your questions. She does work for SparkFun. She's one of our marketing managers, and she's being good enough to help out for the hour in terms of answering some of your questions. One of the questions that I saw go by was, are there any grants to help out with this? That I know of, some of the best and probably the most agile grants that you'll see out there right now are your school district. Usually there's a foundation attached to your school district. They tend to be grants that run in the kind of a couple $1,000s to $500 range. They tend to be the ones that you can land that are the least amount of work, the most output in terms of financial assistance around this type of stuff. So I would specifically ask your school district to see if there's any grants that are out there for remote work like this. They might know of some, especially around your foundation. I got these three ideas or these three ideals from our SparkX division of SparkFun, which is basically our R&D lab. Speed over polish, unabashed failure, which is failing often and failing soon. And then go, go, go. How fast can we get up and going? And as teachers, this is an opportunity for us to do some of these crazy things. I would say the expectations on us are now, I would say completely removed, but they're pretty low. And so it's a time for us to kind of try new things, fail a little bit, stub our toes on things, and keep going. So this 20-20-60 idea is that your prep time should only be roughly about 20% of the time. And then your direct instruction time with your students should be about 20% of your time. And then 60% of the time should be students self-guided, or what I call asynchronous learning time. So I'm stealing some terms from computer science and programming, synchronous being this blocking type idea of one thing happens right after the other. That's your direct instruction. Relatively difficult in a virtual sense to do in terms of managing your students in your classrooms and giving a lecture and having them do something during that talk, or like right now. Learning with your students in an asynchronous way is something that essentially what the internet's built for, what virtual learning is all about. And so you should spend about 60% of your time doing that with your students. It's going to build better rapport with you and your students, as well as just going to get more done in a productive way, rather than, I know a lot of you probably feel like you've been investing a lot of time into doing things virtually. And this, hopefully, the breakdown of this and how this is taught might help. So a little bit about the microbit. If you've never used one before, we'll do a little bit of a breakdown here. At the very top, you have a USB connector. So it connects to your laptop or Chromebook via USB cable. On the front, you have I would say the world's worst display. It's 25 LEDs, so this is 25 pixels that you can use. So 4K television, no thanks, I'll take 25 pixels instead. You have two buttons, an A button and a B button, which are inputs. A light sensor, which is actually the LED array itself. So through some fancy electrical engineering, the LEDs get used as light sensors as well. We have a thermometer on the microbit, so it can tell the temperature. Just know that this is going to be, it won't be the most accurate temperature. It's the temperature sensor is connected to the processor on the back itself, which does get warm over use. So that temperature will be off by a couple of degrees here and there, depending on how long it's been on, things like that. On the back, you have a radio and Bluetooth. So microbits can talk to one another. They can also talk to your cell phone or iPad. The processor itself, so this is the brain of the microbit, the thing that we program. A compass, so it knows which way is north, west, south, east. An accelerometer. So an accelerometer measures movement and motion as well as gravity. So the microbit will know when it's shaken or dropped or thrown across the room or put into a model rocket and shot up into the sky. It is battery powered, so you have a battery attachment in the upper right-hand corner here, as well as a reset button. And the reset button just starts your program over again. So again, the idea that we have hardware, we can program it, and then students can build projects from it is the whole idea behind this thing. Is that this is a STEM tool for being able to build some of this stuff at home. So it's one, you're learning computer science, but at the same time, it's something that I can take a STEM project, something made out of cardboard and popsicle sticks and hot glue, and make it actually interact with the world, make it actually functional. And that's one of the biggest strengths of microbit is taking some of this glitter and hot glue type projects that some of us cringe about when we call it STEAM or STEM, and actually make things blink, make things function, and the students have learned how to do that through programming a microbit. Some examples of these projects: making a cardboard guitar. The one on the right up here is actually building a door alarm for your bedroom. Doing some data logging of the accelerometer and being able to interpret that is something that something that can be done with a microbit. So putting this in a model rocket and being able to see acceleration as it flies up, parachute deploys and comes down, and be able to interpret that through graphs. Kelly, I see that you're asking, kind of like Makey Makey. It does have some functionality similar to the Makey Makey. We can alligator clip things to it. It has capacitive touch, so I can treat it very similar to the Makey Makey. It does not plug in and just function like a keyboard or mouse like a Makey Makey does. I have to program it to do something when those pads are touched. So with those things in mind, because you guys are asking questions and I like them, I'm going to take 2 minutes. I want you to take 2 minutes and open up a new tab in your Explorer, your browser, and go to the microbit website. So microbit.org/projects. And in the chat, I'd like you to just scroll through that really quickly and just share a link of 1 or 2 example projects that you think your students would enjoy. Awesome. Those things are coming through. So thank you all for adding projects that you think your students would enjoy, especially the links, because then that gives other people an opportunity to check them out. One of the things that I enjoy about all these projects is that many of them can be done with just the microbit itself. I'll be honest, SparkFun manufactures a number of accessories, and we sell a number of accessories and kits that go with the microbit itself. But right now, this opportunity is one of the best ways to capitalize on it is if we can get just the microbit in the hands of students, at home, they have plenty to do. We can talk about accessories and things like that later in the classroom, but right now, how do we get these types of activities in the hands of students? So there's a lot there to do. There's a big chunk of activities and challenges and lessons that you can point your students at. So earlier on, you probably saw the thing or comparison asynchronous versus synchronous learning. Again, I took this from some computer science basics around different types of programming. And a little bit of a definition here is the idea of synchronous being code running from top to bottom. And basically, as functionality happens, it goes from one thing to the other. If we compare that to learning, direct instruction, check-ins, and Q&A sessions virtually. So when I look at this, right now I'm giving direct instruction, I'm interacting with you. It's a little rocky at times, lose people here and there. But be able to shorten that down as you're an instructor, shorten it down so that it's small groups and check-ins, Q&A sessions with you directly. Basically want to avoid kind of this longer hour-long session with your students. And when you do that, what I want to do, this is going to be an interactive time with all of you, is that one of the great tools when doing microbits and doing synchronous instruction, again, this is the time where you and your students are on the computer at the same time doing work, is Microbit Classroom. This is a tool that came out right before COVID-19 hit majorly in the United States. And I'm actually going to do a demo for it right now for us. I'm going to do Microbit Classroom. So I'm going to go to this link, show you how to set up a classroom, and then have some of you join the classroom real time. So here we go. I'm going to jump in. Might lose the screen here and there a bit, but let's do this. Let's restart activity. So classroom.microbit.org. This is where you would land as a teacher if you were to jump on this. I'm going to say, show me the editor page, and it's going to bring me to the editor. I've already created something. I'm actually going, if this is the first time seeing MakeCode, I'm sorry, but this is Microsoft MakeCode. It's a block-based programming environment. Blocks are color-based, so I can pull them out of the different drawers here. It's similar to Scratch, but it's for programming the microbit. One of the reasons why we love MakeCode is that there's a simulator on the left-hand side. So whatever I do in my code here, it will actually run in my simulator here. I don't need a microbit right away. I travel a lot, and it's one of those things that if I'm on an airplane and going to do a professional development or something like that, I'll actually write codes and have it running on the simulator rather than having a microbit out and about on an airplane. So I'm going to create a basic program. I'm going to say show LEDs, and I click on this to turn LEDs on my display. And I'm going to make one slightly different to make it an animation. So wink. Oh, this is on start. Sorry, even I make a mistake here. I need forever. So now the simulator should show a wink. So what my goal as a teacher would be at this moment is that I would personally have a piece of code, and then I'm going to share this with my students, because I'm going to have you as students make changes to this and own it. I'm going to have you make your own animation from this piece of example code. So I'm going to click share with students. Click done. Share. Oh, okay. Dashboard. This is the part where all of you get to join. So you get to go to this URL here, so microbit.org/join. You'll be presented with a form that you would fill out the classroom name, which is there. These are all going to be drop-down menus. So Lime, Cat, Tractor, Piano, and then a PIN number, which is 144698. And I have the number of students that have joined right here down below. So I'm going to give you a couple of minutes here to open up a new tab. Again, go to microbit.org/join and join the classroom Lime, Cat, Tractor, Piano. Okay, so 18 of you have joined out of the 30 so far. As you can see, so this is my instructor dashboard. So I have Camille, Clint, Ellen, Luella, Joe, Jim, Kelly, Petra, Steve, Scott. Scott already finished. Wow. So I'm going to open up, let's see here. I'm going to open up Clint's. So he's in progress. He's working. So Clint, I can now see Clint's code. So this is right now, real time. This is Clint's code. He's smiley face and little kind of a conniving face. So he's working on it still. Jen looks like she finished and she turned it in already. So eyes go back and forth as and Clint just finished. Clint finished. So this is a good way that I can be observing students. And the great thing is you can have this open at the same time that a Google Hangouts open or Google Meets or a Zoom classroom. And so you can actually be giving instruction just like right now and be monitoring your students' work. If you need to assess this, so a lot of us are still trying to figure out assessment as things go on. I can download a report for all students as a Word document. So that downloads all the information, including their code and other things like that, so that as a teacher, you're collecting assessments and you're collecting proofs, even though that this is happening virtually, and you're not having to go through and say, okay, go save this to a Google Drive somewhere, and it's probably going to get lost, and trying to access that information is going to be really difficult for you in the long run. It's a lot of time. So this saves you a lot of time in programming with your students remotely. Now, here's the thing. If I close this session, so if I go back to, I can save this classroom, I can download this classroom and end the session. Once I end the session, the students cannot access this classroom again afterwards. So all of this information, all the work students have done and their names and all that stuff, it's downloaded as a file onto my computer when the session ends. Then it's not accessible to them after that. What happens is that if I want to resume the classroom, so I'm going to actually click download. Okay, I downloaded it, actually downloads as an HTML file. And then I can end my session. So if you're in the session right now, I'm sorry. We're ending it now. So I ended it. One thing that I can do is I can relaunch the classroom. Anyways, it asks for you to basically upload or drag an HTML file back into the classroom, relaunch it, and then it gives you that color, tractor, piano, cat again that you can have students come back in and continue working on their code. So if you only did, let's say, a 10-minute session with them and they got halfway through, if you want to load it back up again, they can do that. So that's Microbit Classroom. Free tool, COPA compliant, relatively easy to figure out. It took me about 5 minutes of playing with it to be able to demo it for you. And it's a tool that is just designed for now, right now. So asynchronous is some things not happening simultaneously. It's happening on their own time. My own kids and how they're working through school, I'm seeing this a lot in that my older son works a lot better in the morning. My younger son works a lot better in the afternoon. And so they're having school and they're working through their schoolwork on time that works best for them. And isn't that something that as teachers we kind of always want, is like we want our students to be working at their best during their time that they can work their best. And so that's actually something that's working well. How this shows its head in remote instruction are self-guided projects that students can be working through on their own. Online videos or tutorials. So this is your time to be a YouTuber, teachers. Recording yourself, giving the instruction. So if you need to give some direct instruction, record 5 minutes of video of yourself. Record a webcam looking down and doing a demonstration on a table or on a desk in front of you. Trying to keep it 5 minutes or shorter. And then share that out with your students. Work on a shared Google Doc together. Completing a specific task by a certain time. So instead of saying, hey, you need this done now, and you're putting pressure on them in real time, it's, hey, this is a weekly project, and you have literally until the end of the week, and it's on their time they're working. And one of the things that one of my kids' teachers have done is assignment bingo. So it's like, hey, create bingo, and it's essentially, they wanted them to get 5 assignments done. It didn't really matter, so they made a grid and said, here's the 5 ways that you can read, and reading bingo, connect 5 of them. So one of the platforms, again, Google Classroom, for a lot of us are that way. One thing that I found that actually resonates with students pretty well, because it's video based, and students like to kind of personalize and use their phones, right, their personal devices, their laptops and Chromebooks, to create their own little videos, is a tool called FlipGrid. So I created a FlipGrid for this webinar, as well as some other ones that I've been giving recently. You go to this URL, flipgrid.com/SFE microbit1. The password is Sparkman with a capital S. And you'll see it from me in teacher mode. So this is landing on mine. This is all the different topics, and essentially this is a video forum. So as an educator, as a teacher, I can create different topics, which can be different assignments or different questions that I ask. So for us, the things that I created and started with are, created a welcome video. Some of the things that are more lesson-based, short lesson-based, I call them FYIs. So required things, for example. Challenges and critical questions. You can think of critical questions as like your exit ticket to the classroom. So for example, I'm going to play my critical question video, and we'll go from there. So if I open up my critical question, you can see the video here, and then it's space for people to respond. Normally it does play with this. Settings may be weird, but if you go to that, you can open it on your own computer and respond to it on your own later. So you can actually record a response as a student, and use the video interface that's very similar to any other video interface, where I can record something, and then I can add emojis and things like that as a student. And then I can share out that response. I can, as an instructor, I can give some evaluations on things. So you can respond, and then as a teacher, you can give feedback on the different responses. So this is one way that I would actually include and create assignments for my students. So someone brought up the idea of a project of a step counter. So video of me giving the instructions for a step counter. I'd like you to create it and then add the typed out instructions and stipulations for that assignment. And then what I ask students to do is record your response of you using your step counter. So getting actual feedback in that way. So for us, and if you so choose, if you want to stay engaged with us after this and ask more questions, I ask you that you keep this FlipGrid URL bookmarked or just save it somewhere. Engage with us through FlipGrid, and I will be able to record videos and share information through FlipGrid with you, as well as my email address, obviously, but this is a really good way to kind of practice using some of these tools. From the Microbit website, there's a number of lessons, and I wanted to give you the URLs in terms of lessons. Make It, Code It is, again, what I talked about before, number of project resources. Challenges are more of, I would say, are like projects, right? They're more of the open-ended type challenge, and that can be solved with a microbit. And they kind of focus on different themes. So more agricultural theme or athletic theme, so that step counter is one of them. Tying this into their PE at home is actually something that'd be interesting. Oceanography, different topics. So again, I'm going to open it up for Q&A here in a second. But I wanted to say that we're here. I want to be able to support you as best I can. Whether it's through FlipGrid, whether it's through email, however it is, we want to help you out and try to ideate with you on how to get microbits in the hands of your students. Again, the question about grants and things like that, we will be working through that and trying to figure out and share out as many of those as possible. Megan and I will try to see if we can share some of those out as we find them through our Twitter channel and then go there. And again, urging you to experiment. There's no time like now to experiment and play around with things with your students. And nothing's better than failing with your students. It's actually really fun, and it gets your students more engaged with you at a personal level. So thank you so much. And so I'm going to stay on and answer some questions as they come in, and Megan's doing a good job of answering some of them too. I am going to just answer them verbally as well as they come through, and we'll go from there. So high school technology, there is a Python option, both in microbit classroom. So if we go back to that, you can see you can select Python or you can select MakeCode. So there is a Python option. The only downside of it from a SparkFun perspective with the Python side is that if you're looking at using our accessories, a lot of our accessories do not have Python support yet. So only MakeCode. But if you're looking just the microbit itself, go for it. So Kelly, you talking about your colleagues bought something for $40, so they're cheaper now. The Microbit Go bundle is $16.50. Your colleagues might have purchased our SparkFun Inventors Kit, which is the microbit, a breadboard, and a bunch of electronics components. So it's designed to kind of go from just what we covered today in terms of the microbit all the way up to building circuits, blinking LEDs, all that stuff. Jesus, in terms of an SD card for data collection, we do sell a breakout board that you can hook up to it that you can data log to an SD card. One of the ways that I've found to do this without any hardware accessories is using the radio. So you can, if you have two microbits together, you can have one of them wireless in a rocket, like your examples stated, and beaming data back to another microbit on the ground, which is connected to a computer. So using one as a base station and one of them as the kind of sensor in the rocket. And if you email me, I can send you some example code of how to do that. Again, thank you so much, all of you, for joining us today. I hope that this helps you out in terms of kind of unraveling kind of the ball of twine that we've all been handed of doing things remotely, especially when it comes to STEM and STEAM education. It tends to be very hardware centric. Even if you just jumped on with the simulator and MakeCode this week with your students and try some of these things out, I think that's a huge step forward with trying to do that and maybe be ready for the real physical thing at the beginning of the school next year.